whereby you could be talking to someone, and when you are having a conversation with someone in a telephone, then whatever they are saying you are not able to hear, or you get to hear something different from what they have said. Now that can be said to be impairment. So whatever signal has been sent, but it is not received, or it is received in another format, then that is also an example of signal impairment. And that is normally what we mean by transmission impairment. So when signals are traveling through the transmission medium, and of course, by nature, this transmission medium are not perfect. That imperfection causes signal impairment, and most of the time it will affect how this signal is at the beginning of the medium and at the end of the medium. It could start in one form, or it could start with some several or with some power, but at the end it has different properties altogether. When it has changed its properties, then we normally say it has been impaired. There are three types of impairment which are normally discussed. One of them is attenuation, the other one is distortion, and the last one is noise. And that is what we are going to discuss in this class. So when we are talking about attenuation, basically we mean that the signal is losing its strength, because here we are looking at the wireless signal. And when we are looking at the wireless signal, it is going through the open medium, and what happens? It loses its energy because it is normally packaged with power, or the transmit power, like we were talking about in the antenna. And that transmit power reduces as the signal is traveling through the medium. The reason why it loses this strength is so that it can overcome the resistance of that medium. And when it is losing that, or it is trying to overcome that resistance, then it becomes weaker. Now, in order to adjust, or in order to compensate for this loss, we can use an amplifier in order to regenerate the signal strength. That is why after some distance, you will find that there is a transmitter, or what we are calling an amplifier. An amplifier is basically a physical layer device which will be used to receive the signal, just add some power component to it, and then release it or forward it in the direction towards the destination it is going. That is why we normally say an amplifier, or we call it an amplifier. At the source, this amplifier is basically the transmitter, which could either be a modem or the wireless antenna as we know it. But in between, before it gets to the destination, then that transmitter becomes an amplifier, meaning that it is able to receive the signal, add some power to it, and then regenerate it all together or forward it. So that is how it works. When it comes to measuring attenuation, or that loss of energy, then we normally say it can either lose or gain the energy, and the unit which is used is normally referred to as a decibel. Now, when you are calculating the decibel or the power of that signal, then it will be dB, then it is 10, then log base 10, and then P2 over P1. P1 is the input signal, and P2 is the output signal. So with this basic formula, we can be able to calculate the attenuation, or that loss of signal strength. So at the sender, where the signal is original, we see it like this. Then in between, there is point 1, which is the sender. Then through the transmission medium, through the point 2, whereby the signal has attenuated. As you can see in this diagram, here the signal looks like it has more power because of the amplitude. But here, the amplitude has reduced and it needs to be amplified. And that is where now the amplifier is used, so that as it leaves point 3, it has been increased, or some power element has been added to the signal for it to be transmitted. So here is an example whereby we are talking of a signal that is traveling through a transmission medium and its power is reduced to 1/2. This means that P2 is going to be a half of P1. And in this case, the attenuation or loss of power will be calculated as this, whereby it is 10 log base 10 P2 over P1, whereby P1 is going to be 0.5, or P2 is going to be 0.5 of P1 and over P1. So when you calculate this, you're able to get that the loss is at 0.3, and that becomes minus 3 decibels. So if you come across it in an exam, or if you were to be asked how it is normally calculated, this is a good example to help you in understanding how to calculate the loss of power in that signal. There is also another example here which shows a signal traveling through an amplifier and its power is increased 10 times. So in order to calculate that, this is what is being done in order to get these 10 decibels. And then there is also another one. This one, I would like you to look at it closely, because even in the exam, the questions will be of such manner. Then after looking at the attenuation, let us look at distortion. When we are talking about impairment in terms of distortion, it means that the signal is going to change its shape or form. Now, distortion will always occur in composite signals. Like we said, composite signals are used because you can have different amplitudes and you can have different phases so that they support one another. Now, each frequency component has its own propagation speed traveling through the medium, and the different components will arrive at the destination with different delays, and that is where the aspect of composite signals plays an important role. So it means that the signals have different phases at the receiver than they have at the source, and that is where distortion comes in. Look at this example of a signal here, whereby the original composite signal is here, and then at the sender, or when it is being transmitted, the phases are separated, so that you have the original, the big one, and then there is also the small one in between, and the third one, which is below here. Now, this composite signal is transmitted, and at the receiver, you're getting something a little bit different, meaning that the form has been changed in between or during transmission. So how does this occur? This occurs due to these elements I had discussed initially, that is path loss. If the one of the signals in the composite signal loses path, and it can lose path because of distraction or refraction, then you can have such an experience. Sometimes it's because of shadowing, whereby there is some interference or some opaque object which stops one of the signals. When it stops, then you can have a similar experience again. And then there is fading, whereby some of the signal may lose strength along the way. And when it loses, then you can have the same experience. And that is what happens with distortion. Now, distortion you cannot calculate because it is usually affected at the physical layer, meaning that it is the properties of the medium which are being affected. So the only thing which can be done in distortion is to improve the properties of the medium. That is, if it is wireless, then you need to make sure that you have a clear line of sight between the transmitter and the receiver, or a clear line of sight between the intermediate connecting points. That is, if there is an amplifier, then there needs to be a clear path which is not being distracted or affected by any obstruction. Then now we go to noise. When we are talking about noise, is basically an introduction of any other signal or any other transmission which is not intended to be there. And there are different types of noises. One of them is what we call thermal noise, whereby that is random noise of electrons in the wire or an extra signal. If, for example, it is in the wireless and you have an experience of, what is it called? Is it thunder? Yes, there is thunder, whereby air has some electrons which are being released. Then it can affect the transmission as we know it, and that can be termed as thermal noise. There is also induced noise, which is from motors or appliances, which can also generate signals. So if there is a transmission which is close to maybe some power transmission or base stations, then you can have some extra signals which are generated. And when they are generated, they will affect devices such as the transmitters or the antennas which are being used in the transmission. Then we also have crosstalk. And when we are looking at crosstalk, is same as the two we have talked about. Crosstalk is whereby you have other transmissions which are taking place. So these other transmissions are affecting the one transmission which you are concerned with. So if there are so many cables, for example, if it is wired transmission and there are very many cables, then the transmissions in other cables can affect the transmission in one cable if it is not properly insulated. If it is in a wireless transmission, you can have crosstalk whereby if the frequencies are not clearly defined, or cells in if it is a cellular network and the cells which are with one base station are being interfered with by cells in another base station, because the reason why we create cells is so that we can have reuse of these frequencies. So it means the frequencies of one base station could be the same frequencies in another base station. And if there are two transmissions which are taking place, then there will be crosstalk, because it means those two transmissions are taking place in the same frequency. Then we also have impulse noise, whereby these are spikes that result from power lines or lightning. This happens when there is increased voltage or increased power in the existing transmission. So I hope that one is clear. So here when we are looking at noise, you find there is this signal which is being generated here and it has to be received here, but there is this spike of power which can now be accumulated in this signal or added into this signal such that when you get it at the receiver, it has increased. So how do we measure the signal to noise ratio, or what we refer to as SNR? So this is the quality, or when we are talking about the signal to noise ratio, this refers to the quality of a system which now can tell whether the transmission is going to be okay or not okay. It indicates the strength of the signal in relation to the noise power in the system, because definitely even in normal circumstances, there was always going to be noise generated during transmission. So whatever medium we are using, we would like to know whether it has good strength to support the signal even when there is some noise or power which is coming externally. So it is the ratio between two powers. There is the power of the signal which is being transmitted, and there is the power of the noise which is being generated from outside the transmission. So that is what we need to calculate. And it is normally given in terms of decibels as well. So it will be SNR dB. Right? It is shown here. So in this example, we want to look at the power of a signal, which is like 10 megawatt, and the power of the noise is given as well. And we want to understand what is the signal to noise ratio. So this is how we are going to get it, because it is one should be more than the other. If the noise is more than the signal, the signal power, then the SNR is going to be high. And when the SNR is high, then there is a problem. So usually you would like to have a scenario whereby the noise of the signal or the power of the signal is higher than the noise, so that it can always cancel out the noise. And it is shown in this example. So look at that one, and then you can be able to understand the values of SNR and SNR dB for a noiseless channel, whereby the signal power, when it is higher, then you can always get infinite value of the signal, meaning that it is not affected by the noise. This is very hard to get, but it is the ideal situation. So when we look at these two cases of SNR, a high SNR and a low SNR, how do you differentiate between the two? When we have a large SNR, then it means that the noise will be lower than the signal. And when you combine the two, yes, there is some noise which is affecting the original signal, but it is minimal to such a level that you cannot be able to feel it. But when the signal is small, or the signal has low power, because the amplitude here is indicating the power of the signal, then when noise is introduced, then the signal plus the noise, it is completely affected. And that is the comparison I was talking about, the ratio of noise to the signal. So I hope that one is clear. Any question?